Hello everyone, Mr. Minnick's my name, math is my game. I'm joined today by my favorite Algebra II class ever. Somebody said it's a lie. Yeah, I kind of insulted them earlier. I said they looked like I just melted their faces. But anyway, we're flipping the classroom in there. So what we're going to be doing here is looking at the answers to this homework. And for whatever reason, this homework reminds me of my friend Tim. He actually goes by TJ. That's his name. He and I used to ride ATVs together, and he loves a Mountain Dew. Now, I don't anybody in here like Mountain Dew? Mountain Dew lovers, it's got to be Mountain Dew. Sprite just doesn't get it done. Mellow Yellow, personally, I like Mellow Yellow better than Mountain Dew. But if you're a Mountain Dew person, nothing compares to the actual Dew, right? So my friend always had some Mountain Dew when we were out riding ATVs, and he said, "Hey Matt, why don't you throw me a Mountain Dew?" Now, mind you, you can't drink Mountain Dew with a helmet on, and we are responsible riders. We rode with helmets on. Well, anyway, I threw a Mountain Dew at him and hit him right in the face. Lucky for him, it was a soft drink. All that for that? That's so anticlimactic. That was so wrong. That was just not even right. All right, so describe the transformation of the parent function. If you took notes on this, you'll realize that there are three different types of transformations. There are three types of transformations, and you do need to know what one of those transformations are to be able to answer this question. Sometimes when you ride a bicycle, you wear a special kind of shorts so that your quadriceps don't explode. They're called compression shorts. They're called compression shorts. So the deal is with number two, the type of transformation from the parent function is that we have a compression by a factor of 0.25. And you might ask yourself, Self, how did you know that? Well, the deal is this 0.25, it might be some constant k. It's some kind of constant k, and that k is being multiplied by some function. Now, what I would notice is the value of that number, 0.25. It lives in a certain interval. You know, I live in a certain place. I live in southwestern Trumbull County. That number 0.25, which is our k value, it lives between what two significant numbers? Zero and one. Awesome. So if I'm highlighting some things, if I'm making notes of some things, that's probably one of the three types of transformations. That's probably half of one of the three types of transformations. So that's number two. The answer is it is a compression by a factor of 0.25. All right. We're doing the even ones, I believe. So number four. Four is kind of unfortunate because in my classes that took the notes on this, I didn't give them notes on this. Shame on me. Shame on me. The deal is in number four, if we had a graph that kind of looked like this, and we take f of negative x, what that graph's going to do is it's going to actually make that look like that. Whoa, that's kind of, whoa, it kind of looks like the evil, was it the stepmother or the witch in that fairy tale that looked into the mirror? Who looked into the mirror and said, "Mirror, mirror on the wall"? Who was that? Was it a witch or a stepmother? Or was it a witch that looked into the mirror and said, "Mirror, mirror on the wall"? Mirror, mirror on the wall. What are we looking at if we're looking in the mirror? It was a what? Okay. Who's the fairest of them all? What did I say? Okay. So anyway, what we've got here is a reflection. In my first and second period classes, we didn't specify this kind of reflection. We did talk about a reflection about the x-axis, but this is actually a reflection about the y-axis. Okay, this is a reflection about the y-axis. So remember, there's three types of transformations. A reflection is another type of the transformation. In this case, it's a reflection about the y-axis. Why? Because we have f of x, and what we've got going on here is f of negative x gives us a reflection across the y-axis. To satisfy your curiosity, what else could something be reflected across? If not the y-axis, the x-axis. So if we wanted something reflected across the x-axis, we would have negative f of x. That's reflected across the x-axis. But the answer to number 4 is this is a reflection about or across or around the y-axis. Now those of you watching back at home, you might hear me take a sip of coffee. I'm losing my voice because I yelled last period, not because I was mad, just because I was excited telling about my friend Ferb. It's a good thing my coffee's not hot, because I would have been like the hipster who burned his mouth on coffee for drinking coffee before it was cool. Okay. Moving right along to the next one, number 6. It's one of the evens. Cut that out. Number 6. The graph of f of x equals negative 2x is shown. Describe and graph this transformation. So we're taking f of x, which is this thing. We're taking this thing. Oh my goodness. We're doubling it. We're doubling it. We're multiplying it by 2. So if we doubled it, what that's going to do is take all the y coordinates and make them taller. How much taller? 2 times taller. So if I look at this, if I look at the given function, I have the point 0, 0. So this new one's going to have the point 0, comma 2 times 0, which is still 0, 0. So that still goes to the same point there. So there's no change there. Oh, that reminds me of that reminds me of the one time I swallowed a penny. Actually, a couple pennies, and they took me to the emergency room. And my parents were wondering what happened. And so the doctor came out and said, "There's no change yet." Boy, these are getting worse and worse by the moment. Okay, so here it looks like we've got negative 1, comma 2. So what we would have would be negative 1, comma 2 times 2, or negative 1, comma 4. So negative 1, 1, 2, 3, 4. So the deal is all I need to sketch a line is 2 points, and I've got them. Here we go. So that line is twice the steepness. Now it asks to describe and graph. So because my graph is taller, it's kind of like when you elongate your muscles before exercise. What should you do to elongate your muscles before exercising? You should stretch them. So because of the 2, what we've got here is called a vertical stretch by a factor of 2. A vertical stretch by a factor of 2. The reason that happened is because f of x is being multiplied some number k, and in this case the k value is bigger than 1. Oh man. So if I had to take notes over this, I'm getting all these notes right now. Vertical compression when k is between 0 and 1. Vertical stretch when k is bigger than 1. So when some number k is multiplied by a function, that's either a stretch or a compression. That's one of the types of transformations. Okay. But there's more. It's like an infomercial. But wait, there's more. What about that plus 1 on the end? That plus 1 on the end says we're going to take all those y values and we're going to be adding 1 to it. So we have 0, 0 plus 1, which is the point 0, 1. So we're going to have that point there, 0, 1. And then we had that other point, negative 1, comma 4 plus 1, which is negative 1, 5, which is negative 1, 5. So the deal here, get my green line going. The deal here is that something went wrong there, didn't it? Oh, no, that's all right. Got to think about this one for a minute. 0, 0, 0, 1, 1, 5. I think something went wrong. What happened to my y values there? How are they different? How are my y values different? They're a little higher, right? Didn't they kind of go up by 1? I don't know what happened when I graphed this, but what was supposed to happen is it was supposed to look like this. It's supposed to look a lot like the red one, just everything's up a little higher. What's that? I don't know what I did wrong up here. I got double vision. So the deal is this plus 1, that tells us that the graph is translated up 1 unit. Translating the graph up a unit is actually called a vertical translation. It's actually called a vertical translation. A vertical translation. If I take f of x and add some number k to it, that's going to be a vertical translation up k units, assuming k is positive. Well, translation, you didn't mention that before. So let's think. Types of transformations. Stretch and compression, that's one type. Translations. Now, amongst the translations, there's vertical translations, and there's probably another type too, and maybe we'll get to that. So number 6, describe and graph. We have a vertical stretch by a factor of 2 and also vertical translation up 1 unit. Okay. So let's pick up number 8. Number 8. I haven't given any shout outs yet in any of these videos. I am going to give a shout out this year. Some of you might not have met him yet. We have a really nice young man here who comes to us. He's our exchange student this year, Lewis. I'm going to give a shout out to Lewis. I'm going to give a shout out to Mrs. Guy. Shout out to her for being a huge help. I'm going to give a shout out to the future Mr. Minnick. He's probably in the back somewhere with his feet up on the desk. He won't be on his cell phone, you can believe that. Number 8, can you give an example of a function for which the horizontal translation gives the same resulting graph as a vertical translation? My first and second period classes should be able to figure this one out maybe, because one thing we said, at least in my second period class, is whenever we talk about lines, lines are neat. Lines are really neat. So let me graph just the parent line function, y equals x. Parent function, it's a function from which others are born. If I was taking notes on this section, that's something I'd probably write down somewhere. A parent function is a function from which others are born. And there's 3 kind of parent functions that you should know, and this linear function is one of them. So that's the parent linear function. Now it says, can I give an example of a function where a horizontal translation is where I have f of x plus k like that, where I'm adding something inside some parentheses. It's the same as a vertical translation. I can actually give an example of this. This is a tricky question. So the deal is if I had something like y equals the quantity x minus, actually let me make that x plus 3. Okay, let me make that x plus 3. So I'm going to take this black line, I'm going to clone it. So I've got this other line now, and it's green. It's green, I said. I don't know how to get out of there. There we go. Okay, so I got the black line, I got this green line. Do you see that x plus 3? Do you see inside the parentheses? Now, the deal is inside the parentheses is going to move this graph either to the right or to the left. Real big idea here. Inside the parentheses, let me get my magic marker going. Inside the parentheses tells us that the graph is going to be translated either to the right or to the left. Because it's a plus 3, what would we expect to happen? We would expect it to be translated which way? To the right or to the left? We would think to the right, right? Well, I've got news for you. If we're talking about horizontal translations, what I told my class the other day ago is that horizontal translations are, big fancy word here, counterintuitive, intuition, to think. Counter, the opposite of. It's the opposite of what you think. So you think it's going to translate 3 units to the right? Well, I've got news for you, sunshine. It translates 3 units to the left. Okay? But I didn't answer the question all the way yet. It says, can I give an example where a horizontal translation gives the same result as a vertical translation? And this is so cool. This is awesome. This is gonna blow your mind. If I had another linear equation, y equals x plus 3, so I'm going to take this black line, I'm going to clone the black line, and I'm going to make this new cloned line blue. That plus 3, we saw a minute ago that that's going to translate the graph which way? Hold on a minute, maybe we didn't see it. Or did we? If we had a plus 1, it translates the graph up 1, right? That plus 1 is at the end, not inside the parentheses. The plus 1's at the end. So here we got a plus 3 at the end. So that's going to translate the graph which way? Up 3, right? Up 1, up 2. Dude, wait a minute. Translating it up 3 translated it to the same place as left 3 did. It's so unusual to be loved by anyone. Da 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 da. I think we need Carlton. I think we need Carlton here. So you mean translating the graph up 3 is the same as translating the graph left 3? Yeah. Keep going for a minute. I can watch the whole thing. It's pretty fun. He's dancing to the music pretty well. I hope the audio's turning out okay in the recording and the playback. Take up too much time. Oh, there it goes. All right. He's still going to be moving. Okay. So we got that far. I guess we better get trucking. Better go to the evens. We're looking at whatever's next. 10. There it goes. 10. How is this function related to y equals x? It says graph by translating it. So I guess I got to graph it. I guess that means I'm going to have to get out my graph paper that makes the rap music, huh? We're going to do that. There we go. I really hope that sounds out in the playback. A minute ago we talked about the parent function. What's the parent function? It's y equals x. They even tell us y equals x. That's a parent function. So So there's that. There's our parent function. Now I know that we didn't spend too much time graphing these, but x minus 3, that's 1x minus 3. The y-intercept is negative 3. 1, 2, 3. The sloppy is 1. Over 1 and up 1, over 1 and up 1. So when we graph that, we're going to have something that looks like that, right? How do those compare? It's what? What T word can we use? It's translated which way? It's translated, the green one is translated down 3. Or if we put this in parentheses like that, at the same time it's translated, isn't it right 3 also? So we could say down 3, we could say right 3, both of them are right. Okay. Well, that takes care of number 10. That takes care of number 10, down 3 or right 3. I guess we got to look at number 12. 12's a lot like 10 was. Nothing too exciting going on there. Nothing too exciting going on there. I know you all love that graph paper. Can't wait till we start factoring. Really can't wait till we start factoring. So there's my parent function. What's that plus 1.5 going to do? What's that plus 1.5 going to do? Translate it up 1.5 or to the left 1.5. Either way, it ends up in the same spot. Doing all right? Okay. Well, number 14, make a table of values. Not a big fan of tables. I like to eat at the dinner table, but other than that, I'm not a big fan of tables of values. Make a table of values after the translation, 1 unit down. So I guess all I got to do is have f of x minus 1 here. So all that's going to do is take my y values and just decrease them all by 1. So my y value was 1. What's 1 less than 1? 0. What's 1 less than 0? Negative 1. What's 1 less than negative 4? Negative 5. And 1 less than 2? 1. So that wasn't bad. That wasn't bad. All right. 16, write an equation. Ooh, write an equation. I thought we only wrote equations in geometry. Guess we got to do that in Algebra 2 now, too. Write an equation. For a vertical translation, 2/3 of a unit down. So y equals f of x, but 2/3 of a unit down. Where should we put the 2/3? Inside or outside parentheses? The inside the parentheses tells us if the thing moves to the right or to the left, and it's counterintuitive. It's the opposite of what we think. Outside the parentheses tells us if it's up or down. So consequently, I'm going to put that 2/3 outside the parentheses. And if I want the thing to be translated down, is it plus 2/3 or minus 2/3? If it's up or down, it's the way you think it is. If it's right or left, it's not the way you think it is. So is it minus? There we go. There's 16. For those of you that had to do these exercises for homework, I hope that you're getting them right. For those of you that have to take notes for homework, I hope you got an idea of what to write for your notes. Number 18, 2 units up, y equals f of x, and then what? And then what? Plus 2 in parentheses or plus 2 after parentheses? Plus 2 after the parentheses. There we go. There we go. Last one on this page is number 20. Number 20. For each function, identify the horizontal translation, then graph it. Oh, we get to graph again. I have a couple of these. Plus one, is that right one? Is that left one? Up one? Down one? You would think it's right one. It's left one. So if you don't know what the parent quadratic function is and you're taking notes on this, you got to know the parent quadratic function. The parent quadratic function has a vertex at the origin. It goes through 1, 1. It goes through negative 1, 1. It goes through 2, 1, 2, 3. Goes through 2, 4. It also goes through 3, 9. It also goes through negative 2, 4. And it also goes through negative 3, 9. But we're graphing the translation of that, and this is where you're jealous of me. You're going to be so jealous of me. You're going to be so jealous of me. You know why? Because watch what I get to do here. All I get to do is clone this, and I get to change the blue into red, and I'm just going to drag the thing over. Right? Got him. One thing I would caution you to do when you're doing the homework on this, when you're taking a quiz or test on this, you might want to have two different writing instruments. Maybe a pencil and a pen. Maybe a red pen and a blue pen. Maybe a pencil and a red pen. I don't know, something like that. I'm going to take an intermission and give a shout out to Mr. Dobrin. I hope his surgery's going well. Hope everything's all right there. Also going to give a shout out to anybody who likes the real Mountain Dew, because anything else just isn't the same. All right. The next one we got to look at is 22. It says make a table of values and then graph this modified one on the same grid. Well, that's going to be kind of cool. I don't like the table, but graphing the modified one should be pretty fun. Table of values, x, f of x. I see the point 2, 0. See the point 2, 0. I see the point 3, 2. See the point 3, 2. I see the point 5. What's that look like? 5, 3.5? 5, 3.5. And I see one more clear point at 6, 0. Not to be confused with the 5, 0. That's who will pull you over and give you a ticket if you're speeding. So don't speed. Public service announcement number 1. F of x plus 3. F of x plus 3. So it's going to be the same thing. But what's that x plus 3 in the parentheses? What's that do to the graph? It translates it to the left 3. Oh, there we go. 1, 2, 3. So this one's going to have a weird table of values, isn't it? It's going to have the same heights. It's going to have the same heights. It's going to have the same heights at 0 and 2 and 3.5 and 0 again, but all its x coordinates are going to be smaller, right? Instead of an x coordinate of 2, that x coordinate's going to be what? Isn't that going to be negative 1? And then instead of the other x coordinate being 3 here, it's going to be 0. And then instead of this x coordinate of 5 here, that's going to be 3 less than that, or 2. And then the last one will be 3. That's kind of a weird question. That was tough. I didn't like that one. All right. We're running out of time. 24. 24, reflecting across the y-axis, we would have y equals 3 times negative x, which is y equals negative 3x. 26, stretched by a factor of 4, would be y equals 4x. 28, compression, we'd have y equals 1/2 x. Be careful where you put your x if you make slanted fractions. 30 up 5 and reflected on the x-axis, so I'd have y equals 4x plus 5. And I got to be careful here where I put the negative. Where should I put the negative? In front of the 4? Okay. 32. Describe the transformation that takes f to g. Oh man, ain't nobody got time for that. We'll have to talk about that one in class or another day. We're almost out of time. It's been real. It's been fun. If you're taking notes over this, you can check the YouTube channel or Math Excel for School. Don't forget about the Math Excel. It's due by midnight Friday. Unit 2 review. Have a nice day. See you all later.